Kilauea just erupted for the 46th time, and scientists are stunned because a space storm may have pulled the trigger. Picture it. Lava fountains exploding 700 feet into the Hawaiian sky on Cinco de Mayo morning. Tephra raining down on highways. A plume of ash climbing 20,000 feet above the Pacific. Park visitors at the overlook watching molten rock punch out of the earth like a fire hose aimed at the stars. But this is not just another eruption. This is the 46th time Kilauea has exploded in the same pattern, in the same place, for 18 straight months. And every time it happens, scientists keep noticing the same disturbing detail. Less than 24 hours before this eruption began, a geomagnetic storm from the sun slammed into Earth's magnetic field. No warning, no prediction, just a sudden, invisible blast of solar energy reaching across 93 million miles of space, shaking our planet from the outside in. And then, right on cue, Kilauea exploded. Again. Researchers are now staring at data they cannot explain. A correlation that should not exist. A connection between solar storms and Earth's deepest volcanic conduit that breaks everything mainstream geology assumed about how this planet works. The sun should not be able to trigger a volcano, but the timing keeps lining up, over and over and over. So are we watching a routine eruption from the most active volcano on Earth? Or is the sun reaching 1,800 miles down into Earth's core and pulling the trigger on Hawaii every time it flexes? May 5th, 2026, Cinco de Mayo, Taco Tuesday morning on the Big Island of Hawaii. At 9:47 a.m. local time, the USGS live feed at Halemaumau crater captures the exact moment Kilauea cracks open for the 46th time. The north vent ignites first. A column of glowing orange magma punches through the crater floor and climbs into the sky. Within minutes, the lava fountain reaches 500 feet, then 600, then 700. The eruptive plume boils upward, climbing past 15,000 feet above sea level. By the next satellite pass, it has surged to 20,000 feet. Tephra begins falling between mile markers 31 and 32 on Highway 11. Sparse, lapilli-sized fragments rain down across Namakanipayo campground. The wind is light and variable from the southeast, scattering ash northwest of the crater. Something is different this time. The south vent stays quiet. Only intermittent bursts of spatter pulse from its mouth, as if the system cannot decide whether to fully wake up. In every prior episode, both vents fired together. Not today. Around the overflow zones, lava cools into frothy, porous basalt, hissing as the heat escapes. Steam plumes drift across the caldera. Ash drifts toward Pahoa, where residents are already feeling the familiar micro-tremors that come before every eruption. Park visitors at the overlook stand frozen, phones raised, filming the impossible. Tourists scream. Locals nod. They have seen this 45 times before. The rhythm is now unmistakable. Since December 2024, Kilauea has erupted in discrete episodic bursts, averaging once every 10 to 14 days. 46 episodes in 18 months. No volcano on Earth is putting on a show like this. No volcano on Earth has ever sustained this kind of repeating, rhythmic, almost mechanical eruption pattern for this long. And yet, outside Hawaii, almost no one is paying attention. But what happened in 24 hours before episode 46 ignited is what has scientists rewriting their assumptions about volcanic triggers. Because the trigger may not have come from inside the Earth at all. 23 hours and 47 minutes before episode 46 ignites, something hits Earth from the outside. At NOAA's Space Weather Prediction Center in Boulder, Colorado, instruments register an anomaly buried inside the incoming solar wind. No coronagraph caught the launch. No model flagged the trajectory. No operator issued an advance warning. A coronal mass ejection had traveled 93 million miles from the Sun, completely invisible to every detection system on Earth, folded into the solar wind like a blade hidden inside a river. Scientists call this a stealth CME. You cannot see it coming. You only know it arrived when the planet starts to shake. Then it connects. The interplanetary magnetic field flips negative. Earth's field, polarized positive, locks onto the incoming charge. The two snap together like a circuit completing. Solar energy floods directly into Earth's magnetosphere, and the field begins to tremble. Solar wind speed doubles. Field strength jumps from a baseline of 5 nanoteslas to 11. The BZ component plunges to -10 nanoteslas. Within 3 hours, the planetary K-index spikes to 6.33, a G2 class geomagnetic storm, moderate by classification, unmistakable by impact. Auroras stretch to mid-latitudes. GPS systems wobble. Power grid operators across the northern tier issue voltage advisories. 6 additional hours of G1 storming follow. Earth's magnetic field swings violently up and down, stronger then weaker, oscillating in rhythms that seismometers at high-latitude stations record as measurable ground disturbance. At Hawaii's Uekahuna Tilt Station, the data tells a different story. The magma chamber beneath Kilauea's summit reservoir is still inflating, pressing upward against the crater floor, building toward the critical threshold that every prior episode has required before the system ignites. And then the threshold arrives early. Researchers tracking the eruption sequence have logged this same fingerprint across dozens of episodes. Geomagnetic disturbance arrives. Kilauea responds. The eruption follows within hours. Not every storm triggers a rupture. Not every eruption follows a storm. But the overlap is happening at a rate that no model can explain away. It is happening too often to be coincidence. And that is exactly what has scientists across the world terrified. December 2024. Kilauea's summit reservoir cracks open for the first time in a new kind of eruptive sequence. Nobody knows yet that it will not stop. The tilt data tells the whole story. Magma pressurizes beneath the crater floor, pushing upward over 7 to 14 days until the system cannot hold anymore. Then a sudden discharge. Lava fountains explode skyward. The plume climbs. Pressure releases. The tilt drops back to baseline. Then it starts climbing again. Inflation, eruption. Inflation, eruption. The rhythm is almost mechanical, almost predictable, almost reassuring in its regularity. Then something changes. Around episode 38, the system shifts. The inflation peaks grow taller. The discharge events grow bigger. Lava fountains that once topped out at 800 feet begin pushing past 1,500. Plumes climb past 1,800 feet. The eruptions last longer, release more material, and register higher on every measurement scale researchers are tracking. Then, within 10 minutes of episode 38 ending, a magnitude 4.4 earthquake ruptures directly beneath the summit. The connection between the volcanic plumbing and the structural stability of the Big Island is no longer theoretical. Episodes 44 and 45 break the pattern again, but in the opposite direction. Shorter eruptions, less discharge, lava fountains that barely reach prior heights. The system appears to be contracting, conserving, resetting into something different. Episode 46 arrives faster than anyone predicted. Inflation barely reaches the threshold values logged in prior cycles before the vent ignites. The south vent stays quiet. The radiative power output, tracked by the Morova satellite system in middle infrared wavelengths, still registers Kilauea at the extreme classification. Most active volcanoes on Earth peak at high or very high. Kilauea hits extreme as its baseline, repeatedly, consistently, almost casually. Researchers overlay the geomagnetic storm record on the full eruption timeline. The correlation surfaces immediately. 46 eruptions, 18 months, and a pattern connecting solar disturbances to volcanic discharge that mainstream geology cannot account for, cannot model, and cannot explain away. No volcano on the planet behaves like this. And the timing keeps lining up with disturbances 93 million miles away. To understand why Kilauea keeps responding to disturbances from space, you have to go deep. Not 30 kilometers deep, not 100 kilometers deep, all the way down. 2,900 kilometers beneath the lava fountains, at the boundary where Earth's rocky mantle meets its liquid iron core, something is pushing upward. This is the Hawaiian mantle plume, the deepest, most studied volcanic conduit on Earth. And it changes everything about how this eruption needs to be understood. Hawaii sits dead center on the Pacific Plate, the largest tectonic plate on the planet, covering 103 million square kilometers of ocean floor. Most volcanoes exist at plate boundaries, powered by friction and subduction. Hawaii is different. It sits in the middle of the plate, thousands of miles from the nearest boundary, powered by something that originates far below where plate tectonics even operates. The conduit rises without interruption. From the core mantle boundary, up through the lower mantle, through the transition zone at 660 kilometers depth, through the upper mantle, through the oceanic crust, directly into Kilauea's summit reservoir. This is not a shallow magma pocket feeding a surface vent. This is a pipeline that connects the planet's surface to its deepest interior, running continuously for nearly 1,800 miles. The chain itself confirms how long this has been happening. Stretching 3,700 miles across the Pacific, the Hawaiian Emperor Seamount Chain is an 80 million year record of the Pacific Plate sliding northwest over a stationary heat source. Necker Island, La Perouse Pinnacle, submerged guyos that were once towering volcanic islands, carried off the plume and swallowed by the ocean as the plate moved beneath them, each one a former Hawaii, sunk and silenced. The Big Island sits directly over the active plume right now. Mauna Loa, Mauna Kea, Hualalai, Kilauea, all four volcanoes fed by the same conduit, all four drawing material from the same source. This is not just a volcano. This is a window straight into Earth's core, and something on the other side of that window is responding to disturbances that begin 93 million miles away in space. Every time Kilauea erupts, it exhales. Gas vents across the summit release a chemical fingerprint that isotope laboratories around the world have spent decades trying to explain. And the more precisely they measure it, the more uncomfortable the data becomes. The signature is helium. Specifically, the ratio between two versions of the same element. Helium-4 is the common form, generated by radioactive decay of uranium and thorium in Earth's crust and mantle over billions of years. It is everywhere. It is ordinary. Helium-3 is different. One fewer neutron in the nucleus, almost entirely primordial, a remnant of the solar system's formation 4.5 billion years ago. It does not get made in significant quantities by any process operating in Earth's crust today. At Kilauea, the helium-3 to helium-4 ratio runs 20 to 30 times higher than atmospheric values. The signal is not subtle. It is screaming. This gas is escaping from somewhere that has not been chemically processed since the planet was young. Somewhere that has been sealed, pressurized, and preserved for billions of years. Mainstream geology explains it as a primordial reservoir locked into the lower mantle during planetary accretion, somehow untouched, slowly leaking upward through deep-rooted plumes. But the physics push back hard. During Earth's formation, impacting planetesimals released their volatiles violently. Chemical differentiation drove light elements upward, not downward. Helium, the second lightest element in the universe, should have floated away entirely. Concentrating it at the core mantle boundary requires a mechanism nobody has cleanly identified. An alternative explanation is gaining traction in research circles. Natural nuclear fission reactors operating deep within Earth, generating helium continuously through ongoing radioactive reactions. The precedent exists. The Oklo natural reactor in Gabon, West Africa, operated for hundreds of thousands of years, 1.7 billion years ago. The geological evidence of that reaction is still visible today. If georeactors exist at depth, Kilauea's anomalous helium ratios make complete sense. So do the temperature gradients. So do the magnetic field anomalies. So does the plume. Something is generating helium at Earth's core. Something is feeding it straight up the Hawaiian conduit. And every eruption brings more of it to the surface. Earth's magnetic field is not generated anywhere near the surface. It is born 2,900 kilometers underground, inside the convecting liquid iron of the outer core, churned into existence by a process called the geodynamo. The field strength down there dwarfs anything measurable at the surface. Enormous, primordial, invisible to everything except the instruments sensitive enough to detect what leaks out. And more than 99% of it never makes it out at all. By the time the magnetic field fights its way through 2,900 kilometers of conductive mantle rock, it has shed nearly all of its original force. What reaches the surface, the 45,000 nanoteslas that compass needles and satellite sensors measure, is the residual. The leakage, the fraction that the planet could not absorb. A fridge magnet held in the palm of your hand generates a stronger local field than Earth does at its own surface. The difference is that Earth's field reaches the same strength on the other side of the planet. This is a giant magnet, and most of its energy lives inside it. Now consider what the Hawaiian conduit does to that picture. The plume cuts straight through the magnetic envelope. Bottom to top. Core mantle boundary to crater floor. 1,800 uninterrupted miles of electrically conductive magma, moving heat and material and chemical signatures upward through the exact layers where most of Earth's magnetic energy is concentrated and absorbed. When a geomagnetic storm strikes the outer field, the disturbance does not simply stop at the surface. Induced electrical currents flow through the conductive mantle. Electromagnetic coupling drives pressure variations downward into depths that geologists previously considered unreachable from outside the planet. Hawaii sits near the equator. Surface magnetic swings during a storm are smaller here than at high latitudes, but the conduit beneath it is fully exposed to the deep field and to every disturbance that propagates through it. Kilauea's basalt layers preserve the evidence. Every lava flow that cools below 580 degrees Celsius locks in the magnetic field orientation at that exact moment. Tens of thousands of years of field history, frozen into stone, recorded by the same conduit that may be responding to field disturbances in real time. The sun does not have to cause the eruption. It only has to time it. Hawaii is not a peaceful volcanic island. It never has been. The earthquake catalog since 1900 tells the real story. Dozens of magnitude 6 and greater events, almost all of them clustered around the Big Island. Almost all of them driven not by plate boundary stress, but by the volcanic plumbing system operating beneath the island chain. November 29, 1975. The Kalapana earthquake ruptures along Kilauea's south flank at magnitude 7.7. Tsunami waves slam the coastline within minutes. 2 people die. The shaking triggers an eruption before the ground stops moving. May 4th, 2018. Magnitude 6.9, same region. Largest Hawaiian earthquake in 4 decades. Within days, Kilauea's East Rift Zone tears open across Leilani Estates, destroying 700 homes and burying entire neighborhoods under rivers of lava. These are not random tectonic events. They are the plumbing system talking. Residents of Pahoa, Hawaiian Acres, and Leilani Estates report feeling micro-tremors constantly. Not occasionally, not during eruptions, constantly. The ground beneath the eastern Big Island vibrates around the clock, every day, driven by magma movement through a network of conduits and lava tubes that extends far beyond what any surface map has captured. Now, pull the lens back further. Recent research links the San Andreas Fault and the Cascadia subduction zone as coupled systems that frequently rupture together, contradicting decades of assumption that they operated independently. New findings from the Aegean Sea confirm that Santorini and the underwater Colombo volcano are part of a single connected volcanic field, not separate systems as geologists long believed. The pattern is everywhere. Earth's geological systems are networked across distances and depths that science is still mapping. Kilauea is the clearest signal available. Its conduit reaches the core. Its eruptions correlate with space weather. Its helium signatures point toward deep nuclear processes. Its earthquake history reveals plumbing that connects the entire island chain. Solar maximum is intensifying. Geomagnetic storms are increasing in frequency. Earth's magnetic field is weakening and drifting. Episode 47 is already loading beneath the crater floor. We are watching the planet's deepest systems respond to forces from beyond it in real time, and most of the world has no idea it is happening.